In this tutorial I want to explain how we explain the trends in reactivity with particular reference to both the alkali metals and the halogens. So if we look at the alkali metals first, as we go down the group, so lithium, sodium, potassium, and then of course there's rubidium and cerium and francium after that. We already might have seen that these metals become more reactive. So we have a trend of increasing reactivity. And on the other side of the periodic table, we have the halogens, fluorine, chlorine, bromine and iodine. And we see that they actually do the opposite as you go down the group, in that the trend is for decreasing reactivity. So here, as in other areas of chemistry, size actually does matter, and this is in fact the key to explaining the trend in the reactivity down both of these groups. So here I will explain what I mean by that. This is anatomy period 2, anatomy period 3, anatomy period 4, and we can carry that right down the periodic table. And what we notice, as you may already be aware, that the number of shells that an atom has is the same as the period it's in the row. So if it's in the second period, it'll have 2 shells. If it's in the third period of the periodic table, it will have 3 shells, and the fourth period 4 shells, and so on. And we can see that each time we go down, another shell is added in each new period, showing that effectively the atoms get larger as you go down the group. So what this means, as you go down a group, the outer shell, which is the one that does all the chemistry, becomes further away from the nucleus. And if it's further away from the nucleus, then it is further away from the attractive force of the nucleus. And it is this force, this attractive force of the nucleus, that holds on to the electrons and keeps them orbiting round the atom. And there is another thing to consider here. With the addition of another shell, there is one more shell of negative electrons in between the outer shell and the nucleus. And these are effectively shielding the outer shell electrons, again from the attractive force of the nucleus. These inner shells here, we have more and more of them as we go down. They're effectively getting in the way of the outer shell. And the effect that has is that the force of attraction decreases, of the nucleus for the outer shell decreases as you go down the group, both because of the distance, the increasing distance away, and the greater number of shells shielding the outer shell from the attractive force of the nucleus. So how does that impact on the reactivity? Well, if we look at the alkali metals first of all, here we have lithium, sodium and potassium with 1 electron in their outer shells. The alkali metals react by losing this outer shell electron. So the lower attractive force as the atoms become larger means that this electron is lost more easily, and the consequence of this is that the reactivity increases as you go down and the atoms become larger. The halogens, of course, react in the opposite way. They react by gaining an electron to their outer shell. So the impact of the lower attractive force on the larger atoms here means it is more difficult for these atoms to attract another electron to fill up their shells. And the impact this has as we move from chlorine, fluorine to chlorine to bromine and further down to iodine is that the reactivity decreases down this group. So in summary, the atoms get larger down a group, thereby the outer shell is further away from the nucleus. There is more shielding of the outer shell from the nucleus. All of this resulting in a weaker attractive force between the nucleus and the outer shell. And of course, alkali metals, group 1, lose one electron to react, and this is easier for the larger atoms with the less attractive force. Thereby, as they get bigger, their reactivity increases. Whereas the halogens do exactly the opposite. They gain one electron to react, and this is more difficult for the larger atoms to attract them because of the weaker attractive forces. So we have the same reasons in terms of the increasing size of the atoms, but because the alkali metals and halogens react in opposite ways, we see the opposite trend as we go down a group with the effect of increasing atom size.